Hey everyone, let's create some dust effect. So in the scene I have the helicopters landing on the ground and creating a lot of dust and debris effect. So what I would like to do is to automate this effect. So whenever the helicopter get closer to the ground, this effect should take place. So as you see, we have dust, debris, and uh, yeah. So let's see. So here I have the scene. Let me just turn this off for now. I have some ground, animated helicopter, animated camera, and so the model I have downloaded from the internet and it's free to use. Um, I've applied some basic animation to it, and also I have animated the camera just to tell the story. Okay, so let me start with the ground. So here I have a basic grid, some resolution. I've scaled the grid just to give some uh, scale. Okay, so a little more of the resolution, and apply the mountains up just to uh, create a rocky surface. Then I've created a mask attribute by applying the attribute paint sub. Here is my mask. Okay, and then applied some blur to this mask just to have a nice blending. And here we have the the rocky part, the flat part, the mix to our position with the mix node applied as a mixer. Okay, so here's the ground, and then the helicopter itself. So here we have a few pieces: the body, the propeller, the main propeller, the tail propeller, and the door. For some reason it's been separated. So here I've applied some basic movement to the helicopter, and then I'd like to rotate the main propeller. So I've applied the $F expression, which is frame, and on the Y rotation by multiplying with some bigger value just to spin it faster. And I also would like to have some pivot point to rotate around. So I use the piece of this propeller. Okay, and I've used it by creating the point in the middle of this geometry, which is good as a pivot point to use. All right, and here I'm adding a spare input just to make things shorter, and I'm drag and drop my null, which is the point, and I'm applying the point expression where I would like to my pivot translate. Okay, so the point expression, the -1 is we're referring to our null. The tree is our vector, and in this case its position. I would like to use the first value of our position vector, which is x, and so on. So the y and z. Okay. And this way I have some rotation with the pivot point at this point, and with some expression. If you'd like to know more about expression, you might use this to export by applying some xhelp and point expression, okay, which gives you some examples and explanation of what it does, which is very convenient. I often refer to this export. Okay, so this is our helicopter and its animation, and now we'll move to the effect itself. So here's the helicopter, okay, and I'm deleting everything but the propeller, and I'm detaching more geometry, and I'm fusing, and I'm turning this off just to keep one point. Otherwise it will kill, fuse all the points, and there's nothing to work with. In this case I have this point, so I'm moving it down and subtracting one from another. This way I'd like to create a vector which looks down. So here I have vector which looks down. What I would like to do, I'd like to have this propeller's point. I would like to stick it to the ground. So here I have the ground. Okay. And by using this vector that we created, I'm sticking this point to the ground. So now that I have 2 points, whereas one of them is representing the helicopter, the propeller of the helicopter, and the second one, which is representing the ground, I would like to measure the distance whenever this effect should happen. Okay, so here I'm creating attribute warp, where I'm using both those points to measure. So I'm subtracting them and measuring the distance between these points, and I'm creating this distance attribute, where I would like to check the maximum and the minimum value of these 2 points. Okay, this way I would like to use some values to cause this effect to happen. In this case, I'm starting with my lower value, which is around 5, and this is the minimum. And the maximum, I can use something like, in this case I can use this one, but I'd like to effect starts to happen around like 15. So after 15 meters the effect should take place. Okay, and then remapping this to 1 to 0, and then putting to the color ramp Okay, and this way I have this the point which is on the ground. To get red whenever the helicopter is closer to the ground. Okay, so as you see, if I as you see, we're losing our color, and then whenever we get closer, we get to this point. So this is our trigger part. Now we would like to apply it to the ground and start creating our effects. Here we have our ground with some black color applied to it, and I'm creating a contrast so I could work with the with this piece. Okay, so I created like some simple effect and a little more advanced effect. Okay, so let me start with the simple one. So what I would like to do next, I'm just deleting those black geometry and then cleaning things up, and by using the rate point I'd like to create some velocities which I will apply to the particles. Okay, so here I have the point, and here's the geometry. By subtracting this geometry from this point, I'm getting velocities, as you see. And next we're applying our particles. So since we have our velocity attribute, it will automatically apply it to our particles. Okay, here we have on the surface some amount of particles with some life attributes I've added to inherited velocity. So we're using velocity that we created, and we're applying some more random values to that velocity, and some additional forces, and that's it. So whenever we get closer, our trigger will start the effect. Okay, so if we look through the camera, yeah, the sort of basic effects we can quickly create. Okay, and let's review the second one. So continuing from here, where I have transfer my attributes to the ground, I scatter some points by using the color attribute just to place most of the points on this area, and I'm deleting the points that are not in this area in this case. Okay, and I'm slightly lifting up the rate point just to pushing my particles upwards. Okay, by creating the velocity attribute. And here I'm doing the same. So here we have our points, and here's the rate point, which is in the middle. By subtracting, we're creating this. Okay, this will be our velocity. And if I turn this off, you see it just moves straight from the center. But I'd like to just them to shoot a little bit upwards. And then I'm applying a noise attribute to my velocity in normals. Alright, gone somewhere. Okay, so just to randomize things a little bit. Okay, and here we have our ground as the second input, and our pyro source as a third input. Okay, let me go with the pyro source, and then let me go with the pyro, and then continue with the particles. Okay, so here I have subtraction, which I've already discussed. Okay, so we have points, we have rate point, subtract, and this is our velocity. And now we are doing the simple pyro creation operation. Okay, so this is a pyro source. We are keeping our input, but initializing the smoke, which gives us density and temperature. Then I'd like to multiply this color and some additional multiplication to our density and temperature. As you see, the color and some density multiplier. So we could have our smoke also start to get activated with this trigger. Okay, and then we're rasterizing. So as you see, okay, we're rasterizing density, temperature, and velocity. Velocity here we created so here's velocity of our points. And then the pyro solver. So the pyro solver, everything is by default. The only shape, whereas the buoyancy is, I put some lower value, and turbulence, because we have like very turbulent smoke in this case, so I gave some noise and disturbance. Okay, and some look, but this we can apply later. Yeah, and if I just scrub, so as you see, okay, so I cached this and before exporting this, I've just turn off the color and flame, and here I convert it to VDB, and just to make it lighter, use the 16-bit float, um, and then I cache this out. Okay. Here's our smoke. So after caching this out, I use the smoke as the advection for our particles. Okay. So going back. So also I've applied a pyro-baked volume just to affect some density, shadows, and color as well. Okay. Back to our particles. Okay, so here we have particles. In this case we're using points since we are working with points. Some bigger values, a lot of particles with some lifespan and attributes, again add to inherited velocity, okay, that we've created. And then we have pop advect by volume, which is the third context geometry. As you see, this third one, the rest is the same. Some additional forces just to lift the particles up, then the gravity, and here we're using the second context geometry as our collision. So here's the ground, the second context, second input, and the behavior, the name of the group, and I'd like them to stop. You can work around this, you can create a lot of things, but I simply decided to stop them, and some drag by default, and that's it for the particles. So where's the camera? Just to, so as you see, triggering our particles. Okay, here I have collision with the ground. Let me just switch to the cached version. Here we have the pyro advection, and what I did here, I lifted the collision group a little bit up so it could stay on the ground. Just for visual sake. Okay. And yes, so this is the final cache. And now just to sum everything up, I'm turning those effects back on with the camera, and yeah, this is what we have. So yeah, as you see, it's not very complicated, quite interesting effect. Well, I hope you like it. Thank you very much and goodbye.